Hi guys, and welcome to our continuation with the C# course. This is session 3, and in this session we're going to be talking about some things like structs, value versus reference types, talk about inheritance, some interfaces, and some specialized parameters for functions. So to quickly recap, in our session 2 we talked about creating classes. We talked about disposable, we talked about constructors, we talked about finalizers, we talked about using versus the using statement versus the using keyword, the code use for using, talked about the different types of members, properties, private, internal, public. I think I did a little bit about static stuff, and I talked about the difference between this pointer, not the this pointer because that's from C#, but the this keyword in a static class versus a normal class. So continuing on, we're going to talk today about some other features of the C# language. So what we'll do first is we'll add a new project. We'll start again. We'll start a fresh console app. So to do that to an existing solution, you select your solution in Visual Studio, you go right click, and you add new project. And it just comes up with a new project dialog as we see here. Do a console app, next, and this time, this is where we want it to be stored, and we're going to call it session 3, and then we just go create. And that will create everything for us. And we have a brand new console app, and we can select it as the startup. You can either do it by right-clicking on there and say set up startup project, or select it from the drop-down here. But if we run it, it builds, compiles, and we get hello world again. One thing that we do need to do is we just need to go in and change it to use .NET 5. And we can save all that, run it again. Okay. So what the heck's a value type and what the heck is a reference type? So it's quite fundamental to C# that we have things that are value types. They're mutable, meaning that they can change. And when you pass them as parameters, what you are doing is you are copying that data into a new variable, which is scoped to that function. And therefore, if you change that, then any changes will not be carried out to the caller. So we can demonstrate that real quick. So if I have a static function, and we should call it void. Remember, void is just a type that says, hey, it's nothing, it doesn't return anything, and it tells the compiler not to expect a value, anything to be returned on the stack for this, which is fine. And we shall call it function1, and inside here we will pass an integer, and we should call this integer data. And then what we can do is we can say, okay, let's write out this data to the console. Console.writeLine data. And then what we can do is we'll say we'll do a few other things here as well. So we'll say, okay, so we'll say function1, and then we'll say data, comma data. Oh, actually, don't need to do that. We do this special string interpolation method by putting the $sign in front of our string. It tells the compiler to say, okay, match this open and close brace, and anything that we put in here, it will be a variable name. In which case, it'll say function1 data, and then we will say data equals 99. And we'll write it out again, and we'll say to function1 after. Yeah, well, okay, we'll just leave it like that. And we'll say, we'll create an int original, and we shall say that as 10, 10 being different to 99. And we'll just copy this, and we'll say main, and we'll say original, and then we will say, right, we are calling the function. Calling function, and then we could say function 1, passing in our data, and then we can say after, what the call after is. So what will happen is this will create a new variable called orig. We can do some refactoring. Let's call that to be orig and null. Original, we print out the original value of that variable. We call our function, pass it in, we print it out, we modify it, we print it out again, we return, and we print it out. And what will happen is original won't change. So here we go, main. Here we go. There was our original right here. Calling the function 1 is 10, which is this line here. Then we say data 99, 99 is here, and then we return. And of course we haven't changed anything because data is a brand new variable. So that's passing by value. Now we do have another way to get around this. We can get around this with value types. So if I use ref here, and what that's saying is saying, okay, although int is a value type, by putting the ref keyword here and here, we're now saying we want to pass by reference. So what the compiler does is instead of creating a new variable, it essentially passes the memory location of the existing variable, and we will see that it will change. And here we have that. It's coming in as 10. Here we create it as 10. Call the function. It's coming in as 10. We're modifying it to 99. And when we return, we have now changed the value by adding this ref keyword here, which basically says pass by reference instead of pass by value. Okay, so that's value types. Now, to find out what types are value types, you can look that up in the Microsoft documentation, which I will include a link to in the description. Okay, so that we have that's essentially pass by value and value types and reference types. We'll add a class, and we should call this our test class. And in our test class, we will say it's internal. We don't want it to be outside this assembly that we're going to have. We'll say it's sealed. Sealed means it's closed for inheritance. You will not be able to inherit from this class, which is great. One of the solid methodologies is basically to say, look, make sure that you need to, either design your classes to be inherited from, or you disallow it, which is a good practice to have. We shall create a public int. We shall call this data, and we shall say it's a property. We shall be able to say, okay, let's not do anything here, but we might want to say, let's be able to set the original value, and we can say data equals original value, and we could say data equals 0. Okay, so here is our class that we're going to use to test. We have a namespace here. We don't need to use any includings, not includings. In C# it was #include. We're using C# here, so we don't need any usings here. We're not using any system functions or anything like that. It's just data. Okay. So let's get rid of this. We'll keep the console line. Let's write another function. So it needs to be static because we're calling it from another static function. There's no this member here. Again, it's going to be void, and we're going to say it's function2, but this time we're going to pass in a test class. And then what we're going to do is we are going to modify test class, modify the property. See, I can't type when I'm getting watched. And we'll say that is 99. Okay. That's fine. We shall say var test class equals new test class. Now, a little bit about code construct. We can do many things here. We can call it by its default constructor, which will set it to 0. We can put a number in here, which will then set that property in that constructor with a parameter, or we can use a initialization code construct where we specify the property that we want to set inside our object. This is called an object initialization block. And if we had many properties here, we could set each one of these properties in here. So that's another feature of C# that we have. We shall print out the original one. Then we will call function2, this time passing in our test class. And then we'll write out the data again. And if we run that, so we initialize data to 199, and we have it as 199 here. And then we call our function, and we set it to 99, and then we return from our function, and we then print it out again, and we get 99. Now, why is that? Because this is an object, and we don't need to do this because it is implicit that passing objects as parameter, they are reference types, and so they will be passed as a reference. And so if you modify anything inside the class, then those changes will persist back to the caller. Now, one of the things that we can do, and this is where issues can happen, because we have a test class here, we can do new test class. And what happens here? What happens is that we have essentially passed the test class by reference, but then we are overriding that reference locally in this scope here, in this function scope. And so the call stack will have the return address, the address of where this class is. We have then overwritten that, and we've blown that away. And then what will happen is the compiler then says, okay, we've called a parameter, it's passed by reference, so pass it back. This reference is unchanged, and so now what we have is what's known as a memory leak. We have lost this. We've leaked this object. Now, in .NET, this is taken care of by the garbage collector. However, if this was doing some unmanaged code, so .NET is the difference between, so all the code in .NET is what's known as managed. It's run within the .NET framework, and unmanaged code is essentially what kind of like you're calling out to C functions and C++. And you can write unmanaged code using the .NET compiler, but that's quite advanced. It's not something we're going to go into. But what can happen is you can have a block of code which is unmanaged by the .NET framework, and if you do something like this, then you can end up with a memory leak, which is bad. Okay, so that is the difference between value and reference types. All objects, all classes, or user-defined classes that you create are considered reference types, and things like ints, bytes, booleans, floats, doubles are considered value types. Structs are also considered value types in C# as well. Okay, so while we are talking about parameters, let's let us create something here. So I'm going to create a function, call that, and we should say it won't have a return type. But this time it will have an out parameter. Now, an out parameter is a special type of parameter that has to be set within the scope of the function. In here, we have a compiler warning. It says the out parameter data must be assigned. Well, that's fine. So we can say data equals 99. And that's all we'll do. What we will create is we'll create a new integer, a new variable called result, and we will set that to be 0. Well, actually, let's set it to be -1 because the default is 0, and so we want to make sure that we can see that it changes. We will then call the function, and this time we will use the out keyword again and result. This says this is going to be modified by this function here, and then we will just output the change of this. Okay. And when we run that, we can see that although it was -1 going in, it has been modified and changed by the function. Now this is quite useful because what you can have is we can have a validation routine or a validation function that we can accept some data. So let's say we'll have, for example, let's take a string input, and we'll have the out data, and we can say here if input equals hello, then we'll say data is 99, and then what we can do is we can say return true to say yep, we're good. Let's set data to -1, our error condition. This is quite useful here. So what we're basically saying is we're setting a default, then we're checking the input to see if the validation succeeds. If it succeeds, then we're returning some data and returning true to say, yep, our Boolean is, our function is true. But if this is not, then we want to return false here. And then we can say if statement here, if function for, and we'll say hello. And then we can output some data here, and then we'll say else, and we'll write some kind of error condition here. Oh, my aim is off. Clean that up, and then we'll say function for error, function type for error. Okay, here we go. And we'll say out result. Okay, and if we run that, it will go, no, we got an error. What's the error? Oh, we haven't expected. Okay, where does that come from? Yep. Ah, here it is. And we says, yep, main 99, great, because our function accepted, goodbye. Function data, our input data was correct. We will now say it to be incorrect, and we should have returned false, and we should have an error. And if we do that, see, function for error. Great. In the real world, this is really useful because built into the framework, we have this kind of construct. We can say, actually, what we'll have in number result equals 0, and we will say if int dot try parse 5678 out number result, and we can have this as some valid. This is typically our validation routine kind of situation here. If we run that, we will see that we successfully parsed that string to this number here. And if we put else here, let's just say, let's copy this here real quick. Let me show you what the error is. We'll say int try parse fail. Okay, try parse. Now if I type hello here, and let's clean that up. It'll say it failed because we couldn't convert the text hello into a number. This is better than the other one, the other option that we have, which is parse here. This doesn't return, it returns a number. So what we would have here is actually, I'll show you how this works real quick. Let's get rid of this. Clean that up. There's the class. Okay. We'll say 5, 6, 7, 8. We would expect this to run without a problem, which we do. Great. But if we, again, test the error condition where we put hello here, we will get something called an exception. We get a format exception. The input string was not in correct format. Well, it's not. It's text. It's not a number. Now, exceptions are something that we're going to come on to, but basically one of the rules with exceptions is exceptions really control errors. Something unexpected happened. Typically things like, you open a file. Hey, I want to open this file. The file doesn't exist. You get an exception. File doesn't exist, exception. That's something that you can't control. Sometimes if you're working with database connection fails, you get an exception. Yeah, something that is difficult to check for, and it's something that is unusual that happens, basically. The guidelines from Microsoft basically say you shouldn't really use exceptions to alter program flow because they can be quite expensive to raise an exception. But in this case here, what we would have to do is we would have to surround this, something a little bit later that we'll talk about in a try catch block here. Now, catch, we're going to catch an error, and we'll just say, copy this error here, and we will say int parse error. Now this is perfectly fine to do. We will get a int parse error. We've caught the exception, but the problem is that what we have is we have basically this code construct. If we jump it out to what it compiles to intermediate language, there will be a label in there, and it will basically say, if there's a problem, then we go and jump. We will basically say, if this fails, we will literally jump to here, and that gets kind of nasty. And that has a performance hit as well. So it is much neater to use the try parse with the out parameter in these kind of situations. Another one to talk about real quick is params. Now, what are params? Well, params are they're basically a indeterminate number of parameters that we can have, and we can say, for example, we'll have params of string, and we'll call this string data, and we can say, well, actually, what we don't want, let's have this change this to int because it's a different type. Otherwise, the demonstration won't really make sense. And we'll say console.write line. We'll say this, we'll write the input, and then we'll say for each var input data in string. What we are doing here is we are enumerating over the array. We'll talk about this a little bit later when we talk about loops, because there are different kinds of loops. This is just one input. And what we can do here, come here, and we'll say function for 52, and then we can say 1, 2, 3, 4, etc., 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 etc. And what happens is this actually, the compiler basically gives us two parameters, this one and an array of this one. And if we run that, we get 53, then 1, 2, 3, and 4. That's great. Those are out parameters. Okay, let's talk about inheritance and interfaces really quickly. So let's get rid of this. We'll get rid of this. Let's go back to our test class here. Let's disable that. Okay, so let's create a new class, and we'll call this our base class. On our base class, again, is internal. We don't want it to be accessible from outside our assembly, and that's fine. We'll go with that. We'll go with that right now, and we'll say let's have a public string. Let's call it, say it has a name, and it is fully accessible right here. Okay, let's leave this here. We'll have data and name. Now, let's write a function. We'll say public void display, and we'll say console.write line data. Okay. If I say var t equals new test class t dot display. Okay. Run that. We have a compiler error. Compiler error is console does not exist. Oh yeah, we need to include system. Yep, using system. Great, and we get 0, which is what we'd expected, yeah, because we set it to 0. If we set this to 99, run, we'll get 99 out. Okay, let's talk about the base class. So let's inherit test class from the base class. You do that with the colon, and then you type the name of the class that you want to inherit it from. Great, cool. And now we can run that, no difference, because it's still the same class, still test class. But now I can go t.name. But where is name defined? The name is defined in the base class, so we're accessing this because it is also a base class. And if we run that, that's great. We can run that. We can also put, because we're now inherited from the base class, it's going to know about name. So in the first instance, it'll be blank because it's in the wrong place. But let's move it up here, and we will get 99 and hello coming out. 99 and hello. Great. Let's move the display function to the base class. Yeah, we'll comment this out for a minute. It's important why to show you in a minute. If we run that, we'll get hello, even though display is now on the base class. How do we get data to work? How do we get test class to work, to understand? How do we get the base class to the data? So in C#, it's an object-oriented programming language, and so obviously the fundamentals of object-oriented programming, where we have data encapsulation, inheritance, and polymorphism, all fit in together. So encapsulation is basically doing this. We're creating a class and we're encapsulating data into that class. And we are using code constructs to limit and control access to that data and manipulate that data through functions or messages. This is just a message. Display will be classed as a message. You may read that in different OOP texts. Now, one of the things with the base class is that everything inside the base class, if it's public or protected, the child class won't be able to access anything that's private inside the base class. So if we put in here, I don't know, it's private. I don't know. Let's create an ID. Okay, and then we'll say in our base class, we will create a new ID. And we will denote that with the underscore to begin with to indicate that it is equals, it is part of this class, new good. Okay, that's going to work fine. Yeah, we're going to have that. What we can do is inside, so inside test class, I can't access ID because it's private. No, not new good, it's good dot new good. I can't do that. It's going to go nope, because it says it cannot access a private member. Can't access this protection level. If I want a child class to access a protected data member, we can say it's protected. But we should also change the name to indicate that actually it is it's global. So this is essentially public to this class, private to anything that doesn't inherit it. And so there we go. Here we can now access that. We won't do that. If we want to display the data. But data is created in the child class. Base class doesn't know anything about it. So how can we do that? What we can do is we can say this is now becomes a virtual function. And inside the base class implementation, we're just going to output what we know about. Yeah, we're going to output name because we know about name. And we'll set name. We'll set name to equal base class. Base class. We know that. And if we do that, because it's virtual, we're only going to get, one second. Okay, yeah. So inside test class, because it's, because test class, because, oh, wait a minute. I'm being an idiot. We're setting it here. Okay, so when we run it, we're going to get base class come out because display is implemented on base class. But remember, we also want to output the data from test class, which inherits from base class. But how do we do that? What we can do is we can say we can override display. And we can say, hey, I'm going to override that. And I'm going to say, what we'll do is we'll say, we'll output my data first, or the base class, depends on the implementation. I'm going to output my data, and then I'm going to call the base class to say, all right, you go do yours. And so what we should have is we should have a number, 99, and base class. Great, cool, that's awesome. We now have some polymorphism here because we are altering the behavior of the class depending on the inherited implementation. Now, I can also do something like this. I can actually say the base class, I'm going to create, okay, before I do this, we need to, what we can do is we can say new base class. Yep, and that's perfectly legal syntax. And it perfectly works because essentially, the base class is a class in its own right. It can do things, it can implement things. So we get base class, and then of course we get 99 base class. That's great. But if I want to say, right, if I want to create a pure base class, a pure abstract class, something that cannot be instantiated by itself, it has to be inherited from, I add the abstract keyword. And here, when I do that, I get an error. It says, cannot create an instance of an abstract class. Okay, fine. We can't do that. And if I run that, I'm absolutely the same. 99 base class, because we haven't changed anything. Now, what I can do is I can unbox this. It's called unboxing. And I can say equals t as base class. Can I cast it? This is a cast function. We also have something like this. You may have seen this in C and C++ and other languages where I cast from T to a base class. That's fine. Great. I now have a base class pointer to our test class because we've only ever created one thing here and we're only referencing here. And if I go T display, I'm still going to get the same 99 and base class because that's what we want. Let's change that name to say, actually, we're inside here. So I go in here, I come inside the data, and I'm going to say name equals test class because that's what I am. I'm a test class. Yep. Inside here, I have to do this to basically set that to be test class. This basically says call another constructor, call the default one. If we had something else that did original value, then we can go and do that. Right, so I create our test class, I give it 99, I change the name, and we should get 99 and test class. And we do, that's great. Right. Now, let's put some spaces in so we can see what we're doing a little bit. What if I go B display? B has the implementation of display, as we can see here. So does the test class. But we're calling this as base class. So will we have just the name or the number? And hopefully we'll get the number and the name. Now, why is that? And that is because we have this virtual function here. So the compiler knows that actually, if we have an inheritance of this class and we have an override of this function, if we pass this, if we call this via the base class, and because it's virtual, we call the child implementation of this. If I take out that, it will still run, but we will only get, oh no, we won't. Oh yeah, because we've overridden it. But if I do this, we get 99 test class and test class because we don't get the 99 here because the base class implementation only outputs the name. So that's a little bit about OOP programming in C#. You could write a whole book about that. Right. Okay. Unlike C++, C# doesn't include multiple inheritance. Now, in some languages, I could create another base class. I will say base class 2. And if I do a real quick internal abstract class base class 2, yeah, it's another class. It's perfectly legit as a class, yeah, but it says test class could not have multiple base classes. So like, right, how do we get it right? How do we get it? Now, I personally don't mind multiple inheritance in C++. You can end up with a bad design pattern, an anti-pattern called the diamond inheritance issue. And that's basically where if I have a class, I inherit from another class and another class, and then both of those inherit from another one. You can end up with these strange things. So how do we overcome this? Well, C# uses something called interfaces, and I shall call this as a I display, because we're going to be displaying stuff. It is convention to call interfaces beginning with I. Even though I have this as class, I can change that to be interface, and I can say that to be an internal interface only. It's not exported outside. Great. And I will create my my display function. All functions that are declared inside an interface are public by definition. We don't need any of that. Great. Now I can come back here and I can say let us inherit from the display, and that's fine. And what I can do is display is implemented in here, void display. That's fine. I could even mark this as abstract. I could say abstract, because that means that whoever, not here, sorry, I apologize. Inside the base class, I can mark this as abstract to say whoever inherits from me has to implement display, and that is perfectly legal, and it fulfills the compilers wanting that the function of display has to be implemented in the class that inherits from it. That's absolutely fine. But we'll keep it as virtual, keep everything the same. Here, come up here, override, that's great, and it will still work, except display has been moved out into our interface. And again, instead of what I'll do inside our program here, instead of having var b as base class, if I say is I display, if I could spell, okay, and it's the same thing. It'll work exactly the same because the interface, we're using interface. But what's nice about this is that unlike the class where I can go and say, hey, change the data here, which we can, we get 102, I can't do this. And why can't I do this? Because there's no declaration of that property on the interface. So interfaces are really great at creating what's called a code contract. Essentially what you do is you would create your interface, you define your class's interface, you would then implement that in a concrete class, and what you would do is then you can use various things like dependency injection, for example, to then say use my interface only. You can use factory method as well. Basically, to use a factory method here, what we can do is we can say on our base class, we'll do it on the test class a little bit. Normally you'd have a factory class in itself, but what we can do here is we can say public static I display, and we'll say create new display, and then we can say return new test class, because that is our implementation of this. Yeah, that is our implementation. And then inside our program, what we would have here is we would say var c equals test class dot create new display, and then c dot display. No, not equals. That would compile and it would run. Yeah, and it's 0 this time because we haven't passed anything on the constructor here. But if we hold our over here, it says, look, we are an I display, and we are a I display here. Base class B is now base class, T is test class, C is display, and everything just works. Okay. All right, so that concludes this session. I hope you found it informative. As per normal, if there are any questions or comments, please don't hesitate to ask in the comment section. I will update the GitHub repository with this. The next session, session 4, is probably a bit of a bigger one where we'll talk about, again, a little bit of data types. We will talk about the difference between const and static. Go on to some more string formatting. We'll talk about some enums, which is another data type, and we'll talk about string manipulation, and then some branching the keywords, things like if then, are some switch stuff as well. So that'll be pretty cool. And I hope you found it enjoyable, and thanks for watching. Take care.